And I would probably use your calculator on this one.
Is it okay if I take a picture of it? Make sure.
He's already through.
I know, I saw him. All right, so I'm going to pull up my handy-dandy calculator. And the only reason, why would I ask you to use a calculator on this one? It's what? It's what? I didn't hear you.
Sorry, and why you put
No. Look at it.
complicated?
It's complicated. Why is it complicated? It has all those decimals, and there's no reason for you to work extra hard because there's no way you can make that easier. So y is equal to 0.495 or 459 x squared plus 25.23 x plus 196. Is that 0.827? And graph. Now you may not be able to see it at first, so you might want to either zoom out or do a zoom 0, and that might be able, there it is. So now this is a business aspect, right? Model a company's spending. So are you going to worry about the second and third quadrant, or are you going to worry about the first quadrant? First, because that's the profit quadrant. So which one does it look like? Don't look like that one. Don't look like that one. Don't look like that one, but it looks like that one.
What if our calculator is graphing?
Then you should quit.
I mean, thought about it.
Yeah, do I drop slip, or you just quit coming to class?
I'm pretty sure I entered that equation.
Hold on, let me answer this question. Go to stat, go to second stat. Got there and see if any of them's on. Any of them on? Huh?
You're talking about second stat, which is the list? Okay,
No,
that.
no, I'm sorry. Second, y is equal.
Plot one is on.
Okay, turn it off.
I got plot two.
Turn it off.
Turn it off.
All of them need to be off.
Message coming in on
The
secure
only
chat.
time that needs to be on is when you actually do a statistical plot using list 1 and list 2, which is like your spreadsheet. All right, so here is your, okay, so that's that right there. Now, what's it asking? The spending projected by this model in 1999. Well, you got to remember, 1999, X is equal to the number of years. Okay, 1999 would probably be Okay, 0 is, yeah, 1988. So you have to go, 99 would be what, 11? So you'd have to go to, well, it's out of the range, really. So you'd have to go to, 11. I don't know if that's what they're wanting, but go ahead and do it. Go to 11. Go to x is equal to 11. So go to trace, or go to window, whichever one, table, and go to x is equal to 11. Second graph. Okay, there's 14. There's 11 right there. 532.15, whatever. Now, what if you want to find the actual number? Because this is 11.06. Then go to table, look at the table, and go to 11. And there it is, 529.9. And you feel good about yourself.
Where'd the 11 come from? I got confused.
Well, 1998 is 0.
Okay.
1998 is 10. So 1999 would be 11.
Thank
The value in part B is extrapolation. That's the opposite of interpolation. Interpolation is when you take half of half of half of half of half. All right. If 0 to 10 if 0 to 10 is my parameters, what would be half between 0 and 10? 5. What would be half between 0 and 5? What would be half between 5 and 10? 7.5. I'm taking half of half of half of half to get my increments. Did I stay within the boundaries? Or did I go outside the boundary to get B? I did. Did I go outside the boundary? Yes. Is that interpolation or is that X? Whatever. Just that one. Yeah, the EX. So yes, extrapolation. They probably give you the choice of that one or interpolation. I don't know. I don't know what they give you, but that's what that is. So I went outside of 0 to 10 to get my answer. Okay? So that's that one. 11. All right? This one I'm going to use complete and square, and I'm going to sketch it. Did we go over this test? Okay. I just want to make sure. All right, go ahead and do complete and square on this one. Or, you could quit. Sorry. X squared plus 8x plus blank is equal to negative 16 plus blank. Half of what?
I think the one I got wrong pretty much on here was just because I had trouble with the graphing too.
That's fine. We'll get to it. We'll get to it. The reason I'm doing these is for other people too. Unless you just want me to take the thing. You don't want to do that. I know you don't. All right, what's 8 divided by 2? And 4 squared is? And we get x plus 4 quantity squared is equal to 0. And take the square root of both sides. What's your vertex? Negative 4 and what? 0. And this, take the square root, you get x plus 4 is equal to 0. Square root of 0, is sitting on the x-axis. So x is equal to -4. So what did I tell you? When the x-axis is the same as the vertex, what is it doing on the x-axis? It's sitting on the x-axis. I don't know who that is. Okay? So you don't have anything but the y-intercept, which is 16, and -4, and that's your graph. All right. 13. The two graphs shown to the right have equations of the form blah, blah, blah. Is the value of a larger... What? Oh, is the value of A... Put that in quotation marks. They should have put that in quotation marks. Is the value of A larger for y sub 1 or y sub 2? Okay, so let's first of all, let's look at the actual function. First of all, let's just graph this function. All right. X minus 1, that means we've got a... Let's make A is equal to 1 because that's your parent graph. All right. So -1, that means +1. That means 1 to the right.
Oh, joy.
And then 3 up. 1, 2, 3. So that is our point right there. That's our vertex. And then what is the y-intercept would be what? 0 minus 1 is -1. -1 squared is 1. 1 plus 3 is what? 4. So there's our y-intercept. So this is our parent graph. Does everybody agree with that? All right. Now what they're asking is, and that looks like y sub 2, right? That's y sub 2. We just drew y sub 2. Now they're asking you, is the value of A larger for y sub 1 or y sub 2? Well, remember, what does a large A, this is 1 right here. What does 2, 3, 4 for A, what does it do to the parabola? Does it compress it or does it stretch it? It compresses it, right? So y sub 1 is going to be what? Larger than that one right there. Now that's the way I see how to answer the question. So it should be larger for, I don't know, yeah, y sub 1. Yes, it should be larger. Because y sub 2 is your basic graph. That's the basic. So if you put in a 2 right here, what is that going to make it? It's going to make it go like that. What if you put a 3? 3 is going to look like that. It's going to be thinner. 4, it's going to be thinner. So as the A gets larger, y sub 1 gets thinner. And that's what they're trying to ask you there. Next one. All right. It wouldn't? Okay. Well, if everybody has problems with it, I'll count up how many there are and I'll give you all credit for them. How about that? Because I've never seen these, so they must be new. All right. I guess we're going to do this right here. Thank you. Yeah, because I've never seen Wolfram be part of the test before. This is the one we went over the other day. They're all real numbers. And it's -infinity to 4. I don't know. Let me look and see. I don't know why they would count it wrong. click the reset button in the upper right. Where's the reset button? Right there? Okay.
Is that choose function
Oh, thank you. All right. Select function 2 and use the range and domain sliders to find the range and domain. This is so neat. I still like this. All right, what's your range? Ooh, you can do your little boop. It hits right there. So it's from what? -5 to what? To infinity. -5 to infinity. I love this. I can't wait to do this in Math 110 or next semester. I'll just use it for Math 109. All right, let's do the range. It's not moving. Oh, there we go. Boom! It hits right there at the x-axis and what? There's your range, and it goes to what? Where does it go to? Infinity. Because what have you got on the end of the sky? What do you got right here? An arrow, or an arrow, depending on where you're from. An arrow. So that means it keeps on what? Going. So you know your x values are going to keep on going, and your y values are what? Going to keep on going. So your domain is negative from 0 to positive infinity. So the only thing I can imagine you do wrong here, Mr. Klauser, is you not choose the right function. That's it. So hit 2 next time, or whatever it says do. Because I'll be honest with you, I love this. Let me see what 4 is. Oh, piecewise function. Negative infinity to boop. Now, 2 is not used in the upper function, but it's what? Used at the bottom function. If I could get it to stop there, it won't stop there, but anyway. And then it takes off and keeps on going. So it'd be negative infinity to positive infinity. The range goes from boop, 3 to what? To infinity. But, yeah, 1 does exist because even though it doesn't exist here, it exists over here. So that one fills that one up. That's neat. Those has got to be new. Okay? What's 4? Another piecewise. Now this one, your domain is from negative infinity to 2, and then from 3 to what? No, to 6. Can you include 3? No, you cannot. So parenthesis, bracket, parenthesis, bracket. Range. Ooh, starts right there. -4 to what? 1. To 1, parenthesis, and then from 0 to infinity. You got to admit, those do help you visualize. You just got to do like I did, Mr. Klauser. You got to read the directions. I didn't even see that select function too, so I kept doing the parabola. All right, 18. All right, solve that one using the square root property. In other words, move the 175 over and solve it. That's real simple, right? You get x squared. No, I can't do that. I'm sorry. I'm going to have to write it. I can't write it in mouse. X squared is equal to what? Take the square root of both sides. X is equal to positive or negative square root of 175. Well, that's not the answer. For one, you need to write it in exact and approximate so you'll know how to do it. So over here, we're going to do exact. And over here, we're going to do approximate. And that way, if you do both with all your homework, then you'll be able to do both whenever you need to. Or whenever you need to do a single version. So 175, the first thing I think of is 25. Why? It's a perfect square, right? And how many quarters in $1.75? 7. So x is equal to positive or negative 5 times the square root of 7. So that's your answer there, but they may not want it that way. They may want it like this. 5 times the square root of 7, comma, negative 5 square root of 7. That's probably the way they want it. Now, if you wanted to graph this, then you would do it in approximate. Well, I think 13 is the square root of 169, right? And 14 is the square root of 196. So 13.5 is in the middle. 169 to 196, I have no idea, but 16 minus 9 is what, 7? And 8 minus 6 is 2. 27, does that sound right? So half of 27 is 13. 13 plus 169 is 172. No, 182. Y'all check my numbers. I mean, I'm not worried about the decimals. And half of, I said that half of 26, 27 is 13. Half of 13 is 7. 7 plus 169 is what? 176. So the square root of 176 is 13.25. So I say it's around 13.2. Y'all check me. X is equal to 13.2. And that's going to be 13.2 and negative 13.2. And that's your approximate, so you can graph it. So how does that help you, Mr. Closer? Okay, we got a few more. I didn't know how many questions y'all had. Okay, y'all had 33 because I put in a couple extra easy ones. Okay, so 21. All right, try that one. This one is, it says use a graphing utility, but you could easily use complete the square. We'll use a graphing utility. That way it won't take up a lot of time. Because by now, y'all should know how to complete the square.
How do we get to that?
What?
Nothing.
Hit y is equal to 5x squared plus 16x minus 16 there it is. So it's sitting on the x-axis, right? And it's opening upward. Which one's sit? Wait a minute. Huh? Yeah, let me hit zoom 6. Zoom 6. No, I've got something in there wrong. Hold on. Let me go back. 5x squared. There we go. I know, it's a pain. Minus 16. And I'm on zoom 0. Okay. So it dips just a little bit below, but the way it's set up, I don't like that. So I'm gonna do a zoom out. This is just the way I do it. You don't have to do it that way, but I'm doing it that way. I'm going to get the origin, and I'm going to hit enter. And then I'm going to do a zoom box. Well, I was going to fix the box. Hold on a minute. It's the way the window is, I think. Huh? Yeah, the way the window is set. I'm going to set the window here in just a minute. All right, there's the actual graph. And I don't know, just let me see. I've got 285 right here. Look at there, 300. That's too big. That's way too big. My Y is 828. So let's just narrow that down. And let's go window. And I'm going to go X-min. I'm going to go -10 or -30. Let's go -40. And my X, I'm sorry, 10. And my X max is 10. And then I'm going to go -40.
You said zoom 6.
Huh?
Zoom 6.
I did zoom 6. It didn't do it right. That's why I didn't. I mean, I'll do it again, but there it is. What? I did zoom 6 and it gave me a line. Okay, well, there's that. Now let me do zoom 6. Let me do zoom 6 again.
You have a work email.
I'll zoom out. Yeah.
But you can tell it's not me.
Well, you can deduce which one is not. Okay, there it is. And if you want to, do a zoom box and just do what? Okay, well, I just don't know what I'm doing, okay? I'm just a jerk. There. Now you can do your x-intercepts and hit second function, trace, or second trace, and hit 0. And put the left bound, put it a little bit above the x-axis, the right bound a little bit below the right axis of the x-axis, and then put it right there in the center. And there's your -4. Then move over to the right hand side, hit second trace, 0. Well, go over and put the left hand side, that'll be below the x-axis, right about there, and the right be above the x-axis, and then the center, and there is your other x-intercept. You got something different. That one you should be doing, this one you should probably do on a calculator, but doesn't hurt if you did it by complete the square. That's up to you. I just did it by calculator on this one because it saved time. 25. This would be a calculator question. So let's go ahead and punch that one in. point or negative, y is equal to negative 0.2 x squared minus 32x plus 1. Zoom 6. Okay, that tells us absolutely nothing. So zoom out. Just zoom out till you get to where you can at least get a little bit of grasp where it is. And this doesn't look like I'm doing it correctly, but zoom out again. I'm going to move up a little
Priority
bit.
1 message coming in on secured channel.
Enter. Okay, now we're starting to see a little bit of it. So zoom out again. I didn't know that was there. Did y'all know that was there? Memory? Oh, I did. Okay, so zoom out. I'm gonna put the origin about middle ways. And you're starting to see more of it. So go back up a little bit. There's your function. So now I'm going to hit zoom box, and this is just the way I do it. And I see my vertex is right in there somewhere, so I'm going to hit enter and pull it down and over. And now you found, there it is. Now what does it ask? Finds the x coordinate of the vertex. So go ahead and hit second, calculate, max, and left bound, right bound, and the center, and there is your vertex. Negative 80 and 1281. I'm looking to see if there's any other questions it's going to ask. And then 29, sketch the graph of the following function. Well, I can't do it because it's already done. I can't do it. But well, that's not a big deal. Let me go through and do that question and see if I can do it. If I have a hard time doing it, then I'll take it off. Let me go over to test and pull up your test, and let me see if I come across that one. Two x to the third. Well, a 2x to the third, you find it down here, is a 3-point quadratic tool or 4-point cubic. There's your cubic right there. That's fine. You can do that. And then match it up. Let's go ahead and punch that in. 2x cubed, y is equal to 2x, let me just clear that, 2x cubed, zoom 6, and it looks like that. Now, I've never used one of these, so you might have to do a trace second trace, or just trace, and go down to an even number, something pretty even, or you can. All right, there's 1.5 and negative 6.6. So 1.5, not going to let you go to 0.5.
Yeah.
Huh? Where's the table?
You have a work email.
Oh. Yeah, table. Okay, there we go. Negative 1 and negative 2. And what was the other one? 0, 0. And 1, 2. And then we have to pull up another one. How much? What?
216.
Thank you, sir. And that's the way you do it. You got to have about 4 points.
I don't think that's the same as the
Well, submit test. It's not the same as yours, but that's how you do it. We got it right. It's the right answer. So you just got to do your table and find some points that are definite. Don't use decimals. Okay? Use your table. Second, what is the table? Second what? Second graph. All right. So maybe that'll help you. Take it again. All right. Chapter contents. I believe we're on chapter 4. Is that complex rational equations? What does it say we do? 4.1 through what? Or what does your syllabus say? Okay, let me look at it. 4.4. So it only goes into 4.4? Okay, we'll move on. What does it say, chapter 5?
5.1 to 5.7.
Yeah, that's very important, especially if you go into calculus. All right, logarithmic functions. Say again. It said 4.4 is optional.
No, 4.4.
Well, that's what I asked y'all. I said, what do we cover in chapter 4? And y'all said 4.4 is optional. That's all you said. Dang, gum. No wonder I'm going crazy.
I don't know if we're going to be able to cover everything before the semester ends.
Who's supposed to worry about that? Who's supposed to worry about that? Yeah. All right. Now, look at there. Oh my. Do y'all know how to do that? You better be quiet. Shifts. Oh gosh. I don't think y'all can do this. Let me find one. See if y'all can do it. All right, do that one. Example 3. Graph the functions square root of x and g of x is equal to x square root of x plus 3 minus 4. I want you to sketch the two graphs. All right, you should be done. What do you mean you should be done? It shouldn't take you 5 seconds to do this one. Maybe 10. What's the first one? F of x is equal to what?
Square root of x.
And that's the parent graph, right? So here's your graph. The parent graph for the square root of x is that right there. Now what's the one they give you?
Square root of x plus 3.
F of x. Ooh, that's nasty. F of x is equal to what? Square root of x what?
Plus 3.
Minus.
Multiple.
So what is this? What's that? What? Left. 1, 2, 3. And what's the negative 4? Oh, wait, that's easy. Wonder how y'all knew how to do that. Guess you learned it from another teacher, because I don't teach. I ain't worth the crap, according to some people. I'm sorry, that just irritates me. Now, they're doing all these tables. We don't have to do that because you already know what the vertical and the horizontal shift does. So you don't have to do that. There's one. Well, you don't have to do it, but what is this one the parent graph of? It's the parent graph of x squared, right? So that's parent graph of x squared is this right here. Alright? So what does this one do? Well, what does that tell us right here? That negative tells us it what? It's going to go down, opening downward. And this positive 55 says it's going to move what? To the right 55. And that 4,500 says what? It's going to move up 4,500. So negative 55 will be out here. And then 45 will be up here. So it looks like that. Now, of course, the graph would be a whole lot more accurate if you had graph paper and you actually counted 55 over and you had units of tens maybe, because that 4,500 is going to be hard to graph. Most of the time, a question like this, they're just going to ask you things. They're not going to ask you to graph it, or they'll tell you to graph it in the calculator. So we don't have to spend a whole lot of time on this section because you already know how to do it. That means we can move on through other sections quicker. Yep. One of the early results in psychology relates the magnitude of a stimulus, X, to the magnitude of the response, which would be Y. Y is equal to kx squared, where k is the experimental constant. Compare the graphs of y is equal to kx squared and k is equal to 1, 2, and 1/2. Well, what's the 1? What is, when a is equal to 1 or k is equal to 1, what is that? Parent graph. What happens when a is equal to 2? Squishes it. Gets skinnier. What about 1/2? Stretches it. Y'all know that. Y'all know that. Now, this is a function. Now, you haven't seen too many of these functions, but I think we did. Did we talk about the volcano? 1 over x squared being a volcano? Okay. Well, get your parent graph functions out. The page that I told you to divide up into 8 pages or 8 little boxes, find that graph right quick. Or find that page in your notes. There's two graphs that I may not have covered that day. And one of them is f of x. My shoulder just, pain in my shoulder. F of x is equal to 1 over x. And f of x is equal to 1 over x squared. Do you have those on there?
Yeah.
Okay, so we did cover it. All right. Okay. I just wrote them down. Okay. Thank you. All right. 1 over x will look like this. Converging on the y-axis and the x-axis, but never what? Never touches them. Same thing over here. Now, with the f of x is equal to x squared, or 1 over x squared, you just flip this side up. Like right here, flip it up, and what do you have? You have a volcano. Now, these have the same vertical shifts and horizontal shifts. Let me give you an example. What if I did this? Let's take the red marker, and I gave you f of x is equal to 1 over x minus 2 plus 4. What's my horizontal shift? Right 2. But Hubert, how do you know where the shift point, where's your vertex for these two? The vertex for these two, and I'm not calling it the vertex because it's the highest and lowest point, the point of origin, if you want to call it that, is going to be the origin on both of these. All right, so you move that origin, whatever you need to move it. So you said positive 2, so I'm going to move 2 over, and then I'm going to move what? 4 up. 1, 2, 3, 4. So this is my new what? That's your new origin right there. And then you just draw this here. And that's how you do a vertical and horizontal shift with 1 over x or 1 over x squared. Alright, so let's do 1 over here. What if I give you f of x is equal to 1 over x plus 3 quantity squared. Ooh, that ain't gonna work. Ain't no invisible man. Okay, let's do this. Erase it. F of x is equal to 1 over x plus 2 quantity squared minus 4. Okay, what's your point that you move? Origin, so I'm going to move it which way? To the left, and then what? 4 down, Hubert. Thank you, class. So here is my new origin. So that's how you do 1 over x and 1 over x squared. So just think of your origin as your what? What did we move on the other ones? The vertex. Just don't call it the vertex because some people have a cow when you do that. It's the point of origin. This one is point of origin is there. This one's point of origin is the origin. So you just move it whichever way the vertical and horizontal shift is. Capiche? All right, let's look at this one. This is a health ed question, but because of friction from the walls of an artery, the velocity of blood is greatest at the center of the artery. Dang old high blood pressure, dang old cholesterol. And decreases as the distance r from the center increases. So as you get further toward the walls, the velocity is going to what? Decrease. The velocity of the blood in an artery can be modeled by the function blah, 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 where r is the radius of the artery and k is the constant that is determined by the pressure and viscosity of the blood. That's used at an average blood pressure rate. They use an average blood pressure rate, and they use an average viscosity of the blood. What's viscosity? Good. And how would you know that? From your dang old OIL commercials on TV. Talking about what? Viscosity. Or you might have looked it up in the dictionary. I don't know. But plug and chug. K is equal to 2 and R is equal to 0.1. And that's big R. Now it says graph this function and functions v is equal to r squared and v is equal to negative 2r squared in the viewing window. You don't have to do that because all they're asking you is, first of all, you need to turn this around, and that would be 2 times negative r squared plus what? 0.01. That's the first thing I would do. I would turn it around because nobody knows what this means. So turn it around. And there's something else you need to do. F of x, or v, is equal to 2 times negative r squared plus 0.01. And that's supposed to be squared. Okay, well, this is squared. All right, now, something you need to do here. What do you need to do here? Nope. You can, but that's not what you need to do. What's the thorn in the side? I'm sorry, what? The negative. I think you said the negative. All I heard was the negative. So I'm going to factor out that negative. Why? Because if the negative is with this A, then that tells you what? It's opening downward. Right here, it doesn't tell you anything hardly. So V is equal to negative 2, and that's r squared, what? Minus 0.01. Okay, think. Is this the vertical or the horizontal shift? Nope. It's the vertical. Why? Because where is the horizontal shift going to always be? Attached to the variable within the function of the exponent. So if you had a horizontal shift, it would be r plus or minus 0.01 quantity what? Squared, and then plus 0.01. Or not minus 0.01. So this is your vertical shift. What does the 2 tell us? It's going to be squished. It's going to be more narrow. So negative 0.01 is going to be, real close to here. And then you're going to have, that's the vertical shift. You don't have a horizontal shift, so that's probably going to be your vertex also. Because, yeah, it will be, because this is, your horizontal shift is 0 here. Because you could rewrite this as negative 2, r plus 0, quantity squared, minus 0.01. So there's your horizontal shift and there's your vertical shift. So it's the same thing. So it looks something like this. Or it may be, yeah, should be. They've got it in a different window. So that's what it looks like. So make sure you can turn it around they've got it at a different window because of the decimals. That's why it's spread out, because they've got it in terms of decimals, the hundredths. Yeah, they got it to the hundredths and the tenths, so you would have to spread it out a little bit. Symmetry, even and odd functions. Write this down. The graph of y is equal to f of x is symmetric with respect to the y-axis, and y'all know that. In other words, the y-axis is the mirror, right? And one side is equal to the other side because that's the mirror. The symmetry means mirror. Mirror image. For every point of x and y is also the negative on the left-hand side. So you've got a negative x and a positive x on each side. So therefore, f of negative x is equal to f of x, and this is called an even function. If your function is even, that means it is symmetrical around the what axis? The y-axis. Write that down. If it's even, then it's symmetrical around the y-axis. And how do you check it? F of negative x is equal to f of x. And we'll do an example and you'll see what the difference is. And then what's the opposite of even? Odd. And odd is going to be down the page a little bit. Give y'all time to finish writing that down.
I'm lost.
Where are you lost?
I don't. What am I supposed to be writing?
Right here.
Even if it is even, f of x is equal to what?
F of negative x is equal to f of x. F of negative x is equal to f of x. That is called an even function, which means that it is symmetrical around the y-axis. Means it's the left-hand side looks exactly like the what? Y'all remember Spider-Man, the first Spider-Man, I mean, not the Tobey Maguire Spider-Mans, the second one, where the guy turns into a lizard, the scientist. What does he do to the mirror when he wants to see his other hand? Because he don't have a hand, something happened to his arm. He goes up to the mirror and he does this, and the mirror looks like he's a whole person. He's got both arms. Y'all remember that shot?
I think maybe.
Anyway, the left-hand side looks exactly like the what? The right-hand side. So, if the left-hand side looks exactly like the right-hand side, that means your mirror is what? The y-axis. That means it's odd, it's even, and that means that if you plug in negative x into the function, you will get back f of x. That's what that means. And we'll do some examples and you'll start to see it. Okay? Odd is this one right here. Write it down. And it's symmetric about the origin. Okay. Now what does that mean? What does this look like? Well, it's symmetrical about the origin. It's not symmetrical around the y-axis, because if it was symmetrical around the y-axis, it would look like this. So this is symmetrical about the origin. This side looks exactly like this side, only it's going in the opposite direction. These two are going in the opposite direction too, but these two are symmetrical about the y-axis. Can't believe, I wonder if I could pull that up on YouTube. I know. Thank you. Let me go ahead and we'll end on that note.